right, welcome to the last day of class. So it's a review day, and what I said I'd do today is create videos on any topics that students requested they wanted a review of before the final exam. I got just two requests, bifurcation diagrams and null lines. So I'll create a video for each of those. We'll keep today kind of short. That's kind of nice. Gives you a little bit of time if you've fallen at all behind and want to finish up the homework, because that's an important way to study the new material for the final exam. You can do that, or it just gives you a little bit of extra time to study. Okay. All right, so the first topic was bifurcation diagrams. So I've got this family of differential equations, autonomous differential equations. Y prime is some function of y plus a. It's a one parameter family where a is my parameter. Okay. Now what I've done is I've given you a graph here of f of y. Adding a to this is just going to give me a vertical translation of this. So basically I'm giving you a graph of what y prime is when a happens to be 0. That's an a, it's not a 9. When a happens to be 0, and then if a is positive, I'd be shifting this up. If a is negative, I'd be shifting this down. Okay. Now when I draw a bifurcation diagram, I'm going to have my a-axis here. Okay. And then I'm just going to be drawing phase lines, which are y-axes, that would be the plural of axis, y-axes on which I'm drawing in the equilibrium solutions, and then just using arrows to indicate whether y prime is positive or negative. I'm going to start by just drawing the one where a is equal to 0, because I already have a picture of that. Now notice what I'm doing here is this is a y-axis. On this picture it's vertical. On this picture the y-axis is horizontal. So I'm just going to be translating that horizontal information into vertical information. Okay. So the first thing to notice is that there are 3 places where f of y is 0. But since f of y, if a is 0, f of y is equal to y prime. When y prime is 0, that's my equilibrium solution. So I've got one at a negative y value, one at 0, and one at a positive y value. And it looks like those are roughly evenly spaced. I don't have exact numbers here to mark off. Sometimes I've got a formula so I can get the exact values. Make sure you read the directions about whether I want you to just list, sort of general points or give what they are exactly. Here we don't have the option of listing them exactly because I don't have a formula for f of y. Okay, so those are my 3 equilibrium solutions, and then I just want to put some arrows to indicate the sign of things. So down here, that's below this y value. When I'm representing y horizontally, that would be to the left of that y value, and I can see that f of y is positive. Notice I'm just looking at, is the graph above or below the y-axis? I don't care what way it's moving. I care that it's above the y-axis, so it's positive. That means y prime is positive, so I'll draw that with an up arrow. Between here and here, that corresponds to this interval here, where I can see that f of y is negative, so we'd be going down. Notice that makes this equilibrium point here a sink. Okay. All right, between these two, that corresponds to this interval. I can see that the graph of f of y is positive, and so we'll be going up. That makes this equilibrium point a source. I'm sure that reminds you of certain people. Okay. And then above this y value would correspond to the right of that y value. F of y is negative. So that's a sink. So we've got 2 sinks and 1 source. Okay. Let's take a look at positive a values first. If a is positive, I'm going to be shifting this graph up. Now if I shift this graph up just a little bit, what's going to happen is a point here would move up here, a point here would move up here, a point here would move up here. I'd still have 3 equilibrium solutions. These 2 would just be moving closer together over here, and this one would be moving farther to the right. Okay. But I can see if I move things up high enough, the number of equilibrium solutions I have would change. Because if I move things up 1, this low point right here is at a y value of -1, or sorry, is at a f of y value of -1. If I move things up 1, that point would move up to here, and so I would only have one equilibrium solution where I used to have 2. I'm going to just draw what that looks like. If I move things up 1, I'm going to have something that looks roughly like this. That's my f of y plus 1. I've got just 2 equilibrium solutions. Okay. So let's draw that here. If a is equal to 1. Okay. This point I can see is pretty much halfway in between the 2 equilibrium solutions that I had. So that's going to be here. This point has just moved to the right of the one I had before. When I'm representing my y-axis vertically, that's going to be above the one I had before. And if I now look at this graph, it's positive everywhere except to the right of this second equilibrium solution. So I'm going to have up arrows, except here. I'll have a down arrow here. So now this equilibrium point is a node. This is still a sink. So essentially what happened is this sink and this source moved closer and closer and closer together until they collapsed into one point, and that was a node. Okay. All right, I'm going to just circle that because that's a bifurcation value. A bifurcation value is when the number and type of equilibrium solutions I have changes. And of course, if there is a change, it's got to correspond to a node. When my source and my sink combined, they had to become a node. Okay, now if A is bigger than 1, so if I moved things up just a little bit more, I would lose this equilibrium point. This one would just move a little bit further to the right. So then we'd have something that was positive until we had this sink, and then negative. Okay. So essentially these 2 points collapsed into one, and then poof, it disappeared. All right, excellent. Now let's take a look at negative A values. Negative A values would correspond to me moving this graph down. Again, I can see if I moved things down just a little bit, I'd still have 3 equilibrium points. They'd just be changing their locations slightly. But right now, this high point is at 1/2. So if I were to move things down 1/2, so I'm looking now at f of y minus 1/2, now that point get something that looks like that. This point moves down here. So instead of having 2 equilibrium points, one on either side, I've just got the one right here. And then this equilibrium point just got shifted a good bit to the left. Okay. Now, when I represent that over here, so this would be A equaling negative 1/2. Okay. This point looks like it's going to be about halfway in between where these two were before, so I'll put that right here. We said this equilibrium point is to the left of where this one used to be, and when I'm representing y vertically, that's going to mean it's going to be below it. Okay. And so I can see now my function that's giving me y prime is positive here and negative everywhere else. So I'd have an up arrow here, down, and down. So I still have a sink here, but now this source and this sink combined to become a node. That's a bifurcation value as well. And then if I moved things a little bit to the left, so if A is less than negative 1/2, if I move things down any further, I'm going to lose that equilibrium point entirely, and this one's just going to move further to the left. So I would represent that as this one disappears, this one is just going to be lower down. Oops, running out of space here. I'll just label that's A less than negative 1/2. So it would be up and then down everywhere else. So again, what we have here is that these two equilibrium points collapsed to become just one, and then poof, it disappeared. Okay. Now, don't forget, when we're drawing our bifurcation diagram, we want to connect the dots. So we want to have these phase lines drawn in, but then we want to see the pattern. So I would basically have a curve that looked something like so. I'm going to just even this out so that it looks like a nice smooth curve. Something that looked like so. So I can see, okay, I've got these two equilibrium points that sort of collapsed into one. I've got these two that collapsed into one. But to the right of here, I don't have one like that. To the left of here, I don't have one like this because it disappeared. So my bifurcation diagram is going to look something like